So let's go ahead and graph a polynomial function. And over on the right side, and you can also find this in a book and online many places, are some steps of elements that we want to look out for. And these are things that we already know how to do. So the first thing when we're trying to graph a polynomial function is understand its end behavior. And we determine that by the leading coefficient and the even or oddness of its index. In this case, it's an even and it's a positive, so that tells me that my end behavior both rises to the right and rises to the left. The second thing I want to look for are its X-Intercepts, where I set the function equal to 0, and to see maybe there are some multiplicity issues going on as well. So let's go ahead and factor this guy by setting it equal to 0. Sorry, x squared minus 1 times x squared. X squared minus 1 times x squared minus 1 equals 0. X squared minus 1, I can factor that down to x plus 1, x minus 1. Same thing over here, x plus 1 times x minus 1. So it tells me that I have zeros at -1, +1, -1, and +1. So -1, +1, -1, +1. And since I noticed that the -1 shows up twice, it has a multiplicity of an even amount, and 1 also shows up twice, which has an even multiplicity. And so that tells me that at that 0, the graph does not cross the x-axis, it only touches the x-axis. Next thing we want to do is look for a y-intercept if there is one. So we want to evaluate the function at 0. So f of 0 equals 1. So I know I have the point 0 and 1 on the y-intercept. We also potentially want to look for any y-axis symmetry or origin symmetry. And how we determine that is by looking at our function and evaluate it at -x. And as I start to clean that on up, I discover that my reduced function is x to the 4th minus 2x squared plus 1, which is exactly what I had to begin with, so that I have a function that is symmetrical to the y-axis. And then lastly, I want to determine what are the maximum number of possible terms this graph has, and we determine that by its highest index subtracting 1. Highest index is a 4. 4 taken away with 1 is a 3. So at the most, I have 3 terms. So let's go ahead and see if I have enough information to make a good graph. I know that I have a 0 at -1, a 0 at +1. I have end behavior that rises to the right, rises to the left. I know that at these zeros, it does not cross the x-axis because it has an even multiplicity. I know that it crosses the y-axis at 1 right here. So it comes down and bounces up, comes down, bounces down. And then maximum number of turns was 4, take away 1, which is a 3. I have a turn here, a turn there, and a turn there. So all those things fit. I was able to graph a very complicated polynomial function. And I'm not kidding, these aren't not easy. X to the 4th minus 2x squared plus 1. By going through this procedure very carefully, one at a time, I was able to graph that. And that again is very cool.